In this first video, we're going to switch this to the order dz, dx, dy. And this is actually going to be the easiest change we can make. After this, it's going to start getting a little trickier. So we're going to think about this region that we had, which is, again, between these two shapes, all in the first octant. And I'm going to try to write some inequalities for all of these. So we're going to start with my inequality. What's z between? Z is between 5x squared and 36 minus 4x squared minus 4y squared, exactly like it was before. That's no different. But now what we're going to do is, instead of looking at where they intersect in terms of y, we're going to look at where they intersect in terms of x. So if you remember earlier, we said that when you kind of smush this down along the z-axis, so I'm going to write this up here because this is kind of a pattern that I like to use. So we just figured out our inequality for z. I'm going to smush down on the z-axis now. And what does that look like? We already determined in the previous video that when I smush this down, I'm going to get an ellipse that looks something like this. And we should probably, we're going to need to come up with an equation for this. So let's go ahead and kind of redo some of the work that we had already. We were saying that 5x squared, we're looking for where 5x squared equals 36 minus 4x squared minus 4y squared. The difference, though, is that instead of solving this for y, I'm going to solve this for x. And I don't think that it should be a terribly huge surprise. Oh, no, never mind. I was about to lie to you. It's going to look a little different. So how is it going to look different? Let's go ahead and start by adding 4x squared to both sides. We get 9x squared equals 36 minus 4y squared. Square root both sides. I get 3x equals plus or minus square root of 36 minus 4y squared. And then we finally get x equals plus or minus 1/3 square root of 36 minus 4y squared. But if you recall, we're actually only using the place, I'll label this x and y, we're only using where x and y are both positive. So x isn't going to be between negative 1/3 squared of 36 minus 4y squared and positive 36 minus 4y squared, which we might get if we just looked at the graph. This right half is my positive. This left half is my negative. My x coordinates aren't going between that, they're just going between 0 and that. So my next inequality is going to be that 0 is in between, or x is in between 0 and 1/3 square root of 36 minus 4y squared. So that's my next inequality. And then this part's a little unnecessary. You can probably just figure out what y is going between just by looking at the picture. But now you can do the same thing. You can smush my region on the x-axis, since we just figured out that inequality. If I do that, what am I left with? I have my y-axis here, and I only have the region from 0 to 3 based on our picture here. If you didn't know that was a 3, that's totally okay, and I didn't really explain why it was a 2 either. You can tell that this is where we intersect, where x equals 0. So if you needed to solve for that being 3, you could solve where does 0 equal 1/3 square root of 36 minus 4y squared. And you would eventually get that now we have something like, you can see pretty clearly that it's going to be 36 minus 4y squared equals 0. You can divide both sides by 4 to get 0 equals 9 minus y squared. And then you see y is plus or minus 3, but of course we're only using positive y values. So even if you didn't know that it was this shape immediately, you could tell that it's where this curve intersects the y-axis, so where that curve equals 0. And then you could solve for it that way. So we have all that. We found that region, so now we know that 0 is between y is between 0 and 3. With that, now I can set up my integral, which is going to be the integral from 0 to 3, the integral using that inequality, the integral from 0 to 1 over 3 36 minus 4y squared, using the second inequality, and last but not least, it's still going to be 5x squared to 36 minus 4x squared minus 4y squared. 4y squared up here, and now my order of integration is dz dx dy. Okay, that was the easy one. Now, well, actually, the next one isn't too bad. It's going to get very bad, so, hold your breath until that happens.